Hey you guys, this is xoftc, and in this video we're going to cover some troubleshooting steps to troubleshoot our circuit, just in case you've built the piano, you followed all the steps, step by step, just like it's written, and then you place the battery according to the instructions, and when you try to play it, nothing happens. What to do in this case, how to find where the problem comes from, and how to troubleshoot this circuit, and learn some basic guidelines for troubleshooting any other circuit. That's what we're going to learn in this video. Now before we start, this video assumes that you built this kit and this piano exactly according to the instructions. You didn't try to do anything that is not written, and you definitely didn't do anything that is said not to do in the caution label and the warning label, and you just follow the instructions as is, and when you reach the end it doesn't work. We're going to start with the worst case scenario, and then we're going to take it on from there. The worst case scenario that can happen with this kit is that we accidentally burn the NE555 timer chip, and without the timer chip nothing here is going to work, nothing is going to happen, and there's no real point in continuing to troubleshoot it. If this happens to you accidentally, it always can be solved, and my best advice is just to contact whoever provided you with this kit, and a solution can always be found. But at this point you're sitting with the kit and it doesn't work, so let's look at what can happen. How can we actually burn this chip? The worst case that you can do is if you accidentally connected the positive and the negative in reverse. Now this is something that really has to do with luck. If you didn't use a brand new battery, then it might be that you accidentally did that, or you accidentally touched the leads of the battery the other way around with the battery clip, and that will also reverse the positive and the negative. But right now I'm going to disconnect the positive lead, and I'm going to disconnect the negative lead, and you can see that our circuit is turned off. And I'm going to connect the negative to the positive, and I'm going to connect the positive to the negative. So you can see first of all that our LED is not turning on, and in this case, according to the instructions, we need to remove the battery as fast as possible because something is not going right. But in this video I'm just gonna leave it like this for a few seconds, and we're just gonna see what happens. Now if this is the case, you will start first of all slowly feeling some heat coming out of your circuit, and that is the NE555 heating up. And then if you touch it, you will actually feel that it's very hot. You can't really touch it, and that's not a good sign. The next thing that you're going to notice is that there is some burnt smell coming out of it, and that is because everything is heating up here. The chip, the breadboard, it can burst into flames all of a sudden, and if you leave it like that, eventually the chip will burn, the contacts between will burn, and then there will be no more closed circuit to work. But right now, as you can see, it's connected the other way around. We left it for some time, and I'm going to disconnect the negative lead, and I'm going to disconnect the positive lead. Connect the positive back into the positive rail and the negative back into the negative rail, and let's see what happens. So right now I've connected it back the way that it should be. Again, if you accidentally connected them the other way around, whether like this or whether by just accidentally touching the battery clip in the other way around, it's really a matter of luck. If the battery wasn't completely full, or it was a used battery, there can be a chance that nothing happened and we just let the chip cool down a little bit and it will go back to normal operation. But it could be that it's burnt, and whether we have tunes or not, we need to know if it's still working properly. And to do that, we're going to carry out the following steps. Right now, everything is connected as it should be, assuming, and we're going to remove the C2 capacitor that goes between the NE555 and the buzzer, the 100 nanofarad capacitor. We're going to set it to the side. We're going to remove the LED, and we're going to take the LED and just spread it a little bit so that we can put it in place of the 100 nanofarad capacitor. So where the capacitor was, we're going to place the LED with the negative side of the LED going into the buzzer side and the positive side going into the NE555 chip. We're going to do it right now. If the chip is working correctly, we should immediately hear a high-pitched sound coming out of the buzzer. But if the chip is not working, then we won't hear a sound and the LED will also not turn on. So let's try it right now. I'm going to just connect it. And you can see that there is a high-pitched sound. And the LED also went on. So that is an indication that the chip is still good. So this time we had luck. I'm not using a full battery. It's not a new battery. I've used it in different demonstrations. So we're in luck and the chip is still working. Just to show you what happens if we have a burnt chip, I'm going to replace the chip here with a burnt one. And let's see if we get the same tone coming out of the buzzer. Okay, so I've connected a burnt chip and here we have the good one. So I'm going to do the same thing. I'm going to take the LED and I'm going to connect the negative side to the buzzer and the positive side to the NE555, exactly where the 100 nanofarad capacitor was. And once I do that, and our circuit is connected, you will see that there's no pitch, there's no high-pitched sound, there's nothing coming out of the buzzer. We're not hearing anything, and we're not feeling anything, any heat coming out of the chip. But when the LED is not on and the buzzer is not providing a sound, that's pretty much an indication that the chip is no longer working as it should work. And in some cases, you will have a chip that will show you an LED and will produce a sound. But when it does it, you will feel that it's heating up. And again, that is not a good sign. When anything heats up in your circuit, that's not a good sign. And you should immediately disconnect it and then start to troubleshoot it. So this was the worst case scenario, the scenario where we accidentally burned the chip. Again, it's a matter of luck, which battery you use, how much voltage the battery has, and how much time it was connected the other way around. But if you have connected it the other way around, 99% of the chances are that the chip is either completely burned or will no longer work as it should be working. So I'm going to replace this chip, and then we're going to look at some other cases that we can start troubleshoot ourselves. Okay, we're back, and we have a good chip inside. I know that it's working right. We have the battery connected, we have the LED that is on, and once again, when we press the keys, nothing happened. So at this point, we can almost be 100% sure that one of the connections is not right. It could be that you've placed this diode here the other way around, so you need to check that one. And the best suggestion is to simply go step by step and just look that everything is connected as it should, especially all the jumpers that need to connect different things together. But let's look at another test that we can do just to try and sort of isolate different things. Here we have the LED again, and it is on, and we basically always will use this LED as a sort of a troubleshooting tool. It's not the right way to go about it, but since you only have this piano and assuming no equipment and no knowledge, then we're going to go with that method, and hopefully it will teach you how to also troubleshoot other circuits in the future if you're going to continue with this hobby. But let's look at another thing that we can do, provided that we have assured that the chip is working. We hear the high pitch tone coming out of it when we tested it, just like we did previously. So next we're going to take the LED. Once again, we're going to make a little adjustment here just so that we can fit it nicely between the positive and one of these resistors right here. So I'm going to set this up now, and again, what should happen in principle, provided that our diode is connected the right way, is that we're going to hear a sound coming out. We're going to hear a sound, and we're going to see also the LED turning on, and we can do that right now by connecting the positive, always the positive to the positive, and the negative goes into one of these rails here with the resistors. And when I do that, you can see that there is a sound coming out. It's okay that the LED doesn't light up, that is fine. If we do it on the other end, we can see that it does happen, and we can also hear that the buzzer is sort of turning on and off. The plate inside is oscillating, but when we do it on the lead that actually goes through the resistor, we should be hearing a sound. And this will happen on every one of the leads that we're going to try it on. And depending on the resistance of the values of the resistors, either we will hear a sound, or either we will hear a sound and the LED will turn on. But still, we heard a sound, we saw that everything is working, and when we press the keys, nothing is happening. So at this point, we have sort of isolated the circuit. We know that this part here is working right with the chip and the buzzer and everything is functioning. So there's either some problem with the connections that come from this end to the keys, or there is a problem with this long conductive strip that needs to make all these connections. And if we look carefully, as I said, most of these problems come from either wrong connections or loose connections. We can already see that here I've made a little mistake and I've connected it not on the right rail. So basically we don't have any power coming to this part, and it can't provide any power to the rest of the parts. So none of the keys are working, and I'm going to just reset it in the right place. Take this wire, set it right here, and we get a tone. And if we try each one of them, we come to this one, and this one doesn't produce a tone, but all of these do. And this can happen, maybe some of the keys are working and others don't work. And if that's the case, then since all of them are working now, the first thing that we're going to look at is this specific key, and we can see that once again I've made a mistake and I've connected it not in the right place. So I'm just going to set this connection back, and now it is working. It's working as it should. Everything is working, all the sounds, all the tones. An example of when some of the keys will work and some of the keys won't work is, for example, if we make any changes to one of these jumpers here. So I'm just going to remove this one. I removed the jumper. It can also be connected in the wrong place. But then what we see is that The first 3 keys don't work, but the rest do work. So that would mean that there is something going wrong at this end that connects all of these keys into the single line. And if we place it back the way that it should be, then right now everything is working as it should. These are the basic things that you can try to troubleshoot. We tested the chip just to see that, that it's working correctly. And once again, if at any point, doesn't matter whether it's this piano or any other circuit that you're trying, if you're feeling heat coming out of any of these components to the point that you can't touch it or that it's really noticeable, then you already know that there is something wrong going on, and you immediately disconnect the circuit from the battery just like that. You don't leave it on, you don't do anything like that, you just disconnect it. And we've checked the diode. We've seen that the diode is not in reverse, because if it's in reverse then it won't allow any of the current to flow into the chip, so that we can't produce really any other frequencies. And we've isolated the circuit, so we've isolated this part of the circuit from this part and from this part, and just figured out where the problem lies. And this is basically the way that you go about all circuits. There are tools for that, and there are special tools that you can use. But since you don't have them, and we're assuming that this kit is the first one that you're building, we just took some basic methods of troubleshooting using this LED, and it should work. It works, and it should work. So that's it. I hope that you like this video, and if you're having any other problems, then you can always, again, contact whoever supplied you with this kit. It is an open source kit. Anyone is allowed to produce it and do whatever they want with it using xoftc's instructions. I hope it helped you solve the problem that you have, and if not, well, it's something that you learn from. Troubleshooting is something that you do most of the time, hobbying with electronics, just trying to figure out where problems come from. But that's it. Thank you for watching.